Hey there, Neutron Tech crew, we're back with Meanwhile in the Garage, and this time they're constructing a hydraulic press from the ground up. What we're about to witness is pretty impressive, creating a 20-ton shop press without buying one off the shelf. The target here, an H-frame press that can deliver a whopping 20 tons of crushing power. That means the frame needs to handle 40,000 pounds without buckling, and there's gotta be a hydraulic system strong enough to pump out that kind of force. They're taking chunky steel pieces and a 20-ton bottle jack that's seen better days and turning them into something seriously useful. It's a perfect example of how yesterday's junk becomes tomorrow's workshop workhorse. The material choices here are actually really interesting, especially considering this is a DIY build through and through. Steel won out because it checks all the boxes. It's strong, it's tough, it can bend without snapping, and most importantly, you can find it lying around in scrap yards everywhere. For the frame, they went with mild steel, probably something close to A36 grade if we're getting technical. This stuff can handle about 250 MPa before it starts to give. Here's what's great about mild steel compared to brittle stuff. It bends before it breaks, which gives you a cushion of safety. That flexibility really matters in a press like this because if you accidentally apply force the wrong way, you're creating all kinds of weird stress points throughout the structure. The long pieces running through the frame came from structural steel pulled off old machinery and factory leftovers. Using I-beams for the top crosshead wasn't random. These beams are shaped specifically to fight off bending when force hits them along their strongest direction, which is exactly what you want here. An I-beam's shape does something clever. It pushes compression forces straight through the middle section, while the top and bottom edges fight against any bending that tries to happen. That makes it absolutely perfect for the horizontal piece, taking the full 20-ton hit. As for the vertical posts and bottom frame, they picked beefy rectangular tubes with thick walls. When choosing materials, rust and prep work couldn't be ignored. Salvage steel typically shows some degree of oxidation. That's just what happens when metal sits around getting wet. The good news? In most situations, that rusty layer stays on the surface and doesn't eat through the structural sections. Once you clean them up properly, these components are still solid and ready for serious work. Cleaning off that surface rust meant breaking out the grinders and sanders. By aggressively removing the oxidized layer, fresh metal gets exposed, smooth, clean, and perfect for welding with proper fusion. Now here's where things get interesting. Store-bought presses come with everything built in, including the pressing head. But when you're rigging up a bottle jack for this kind of setup, you can't just slap it together. The foundation matters more than almost anything else. This lower assembly does serious work. It catches the entire vertical force that slams down through the frame when you're pressing. Beyond that, it needs to keep everything rigid, allow the whole thing to move around, and stay planted when the pressure's on. Starting with the RHS beams means dealing with whatever crud has accumulated over the years. Seriously corroded ends? Cut them off. Then it's grinding time. Lots of it, until you're down to bare metal. That clean surface isn't optional. It's what allows welds to actually fuse together the way they're supposed to. After that comes precision cutting with abrasive wheels to get exact lengths. For extra strength where pieces meet, chunky steel plates get machined to cap the ends. Once the main rectangular outline is locked in, the focus shifts to making this thing mobile. Here's a clever touch. One of those bigger rectangular beams gets sliced lengthwise to create a storage slot right in the base. You can see this happening during the cutting phase. Now for the vertical posts, the uprights. These are what take the hit from all that downward force, keeping everything aligned and stable. What makes RHS better than something like C-channel or angle iron? The walls are the same thickness all the way around, which means stress gets spread evenly instead of concentrating in weak spots. That's huge because it means the press can handle not just straight down pressure, but also any sideways forces that crop up. Figuring out the right size for those RHS beams isn't guesswork. It's math tied directly to how tall the whole frame needs to be. You've also got to factor in how far that hydraulic jack actually travels and where you'll need the table to sit at different heights. Now here's where things get tricky. Drilling those vertical posts. You need a bunch of holes going straight through, and they have to line up like they're on a laser grid. After all that drilling and cleanup, those columns get stood up on the base you built earlier. This part's no joke. If they're even slightly crooked, you're setting yourself up for trouble. The hydraulic pressure will push sideways instead of straight down, and that's a recipe for disaster. Next up, making the pins that do the real heavy lifting. These solid steel rods are going to shoulder the entire pressing force when the machine's running. For this job, you start with quality steel bar. Nothing cheap or sketchy. The raw material gets spun on a lathe until it's perfectly round with an exact diameter all the way across. The actual pressing surface came from another chunk of hefty steel. An I-beam section got chopped down to bridge the gap between those uprights. Some folks used two smaller I-beam scraps sitting next to each other, but this build went with one thick beam instead. With the pins locked in, the table sits solid from below and handles the full crushing force without flinching. But here's the thing, this table weighs a ton, literally. So the builder added something smart, little lever handles. What really stands out is how this junk metal transforms into something genuinely functional. Before anything else happens, every single piece gets stripped of rust down to bare metal. Sounds boring, right? But this step isn't optional. It's what determines whether this thing holds together for years or falls apart when you actually need it. When you're working with an arc welder, rust is basically your enemy. It creates all sorts of problems, trapped pockets of air, weak spots, and bonds that just won't hold properly. That's why you can't skip the cleanup. Getting rid of every trace of corrosion isn't just about making nice-looking welds, it's about creating genuine metallurgical bonds where the heat affects the metal. The builder here goes hard on this, running through several different abrasive cleaning techniques one after another until the surface is truly restored. Here's where things get creative. The builder isn't just recycling metal. There's a pair of old gardening scissors getting a second life too. It's pretty clever when you think about it. Those comfortable handles that made cutting plants easier, they're being retrofitted as control components for the hydraulic system. Now that the frame is built and everything's lined up correctly, things get serious. The next phase is all about the hydraulics, and it revolves around a heavily modified commercial bottle jack. Think of this component as the machine's powerhouse. It's what creates and manages those crushing forces the press needs to work. Here's the catch. Simply bolting the jack into place won't cut it. The builder needs to dive deep into its internals, reworking the plumbing extensively so it can handle the specific demands of this custom shop press application. The hydraulic unit being modified is a 20-ton bottle jack, the kind typically used for jacking up vehicles. Step 1 is taking the entire bottle jack apart. Opening it up reveals how everything works inside and lets the builder figure out exactly what this jack can and can't do. The seals get examined closely, checking for flexibility, even wear patterns, and any breakdown from sitting in hydraulic fluid for who knows how long. Construction is moving forward, and the builder makes absolutely sure every bit of insulation gets installed correctly. This is also when they take time to inspect the pressure relief valve thoroughly. Sure, that safety feature works great when you're lifting things, but when you're building a dedicated press, you might need to adjust how that valve is calibrated. One really clever thing happening at this stage is reworking the jack so it can run with a pneumatic assist system. Out of the box, these jacks work manually. You pump a little handle by hand. For this particular press, the builder reworks how the internal pump functions so it can run alongside an external compressed air supply. What you end up with is basically an air-over-hydraulic combo unit. Once the hydraulic system is locked into the press frame and everything's connected, the builder moves forward with some final testing under simulated loads. This involves running compression cycles with lighter loads first, then slowly ramping things up until they hit the full 20-ton capacity. Now that the hydraulic press is built, working smoothly, and proven to be structurally sound, the builder shifts focus to cleaning up surfaces, adding the finishing touches, protecting it long-term. After the mechanical cleaning is done, they follow up with a chemical degreasing process. Once everything's spotless, it's time for corrosion protection and the finish work. The builder uses a direct-to-metal industrial paint system, applying it with spray guns to get a sealed layer over every part of the frame. These coatings are built to handle minor surface flaws while still creating strong chemical adhesion to the steel underneath. They put down several thin, uniform layers to keep the paint from dripping or puddling in tricky spots like gussets and where the springs sit. While the coating work progresses, there's another crucial job happening at the same time, bringing those industrial caster wheels back to life. These tweaks might seem minor, but they make a massive difference in how smoothly the thing rolls around the shop and how safely it handles when it's loaded down. The custom-built ram extension gets another pass with the polisher to knock out any tiny flaws left on the surface. The hydraulic release valve goes through cycle after cycle in a controlled environment. The MWIG logo gets created through precise cutting techniques. A plasma cutter carves out the entire plate, creating letter shapes that either stand proud or sink into the surface. Now comes the moment where everything comes together, the final commissioning stage. This is where all the calculations, all the careful metalwork, and all the testing merge into one ultimate proof that this machine actually works. Testing starts light, with throwaway pieces or test materials taking the initial hits. Once the press handles those smaller loads without issue, the pressure climbs steadily toward maximum capacity. When it finally hits full power, you're looking at a real simulation of the toughest conditions it'll face, which reveals any hidden problems in the welds or weak spots anywhere else. The frame stays rock solid under pressure, and the hydraulics show no signs of leaking past seals or fluid acting weird. With everything checking out perfectly, the press gets its official stamp of approval for permanent shop duty. What started as a heap of throwaways and forgotten metal has become a legitimate heavy-duty piece of shop equipment. Looking at the finished product, you can see proper engineering throughout. This isn't some cobbled-together experiment built from whatever was lying around. At its core, this press is all about understanding how forces travel through materials, how loads spread out, and why backup systems matter. The closed H-frame design does something smart. It funnels all that crushing force straight down through the vertical columns. The result? Zero bending moments, barely any sideways flex, even when you're pushing a full 20 tons through it. Look at the front of this thing. There's a MWIG logo that's been carefully crafted by hand. But here's the thing, it's not just sitting there to make the machine look pretty. This logo actually functions as an official industrial certification, proof that every step of this machine's creation, from the first sketch to the final product, was controlled and executed by one team. It's basically saying we owned this project from beginning to end.